Here's a weird fact. Modern neural networks are so over-parameterized that on paper, they should overfit like crazy. Memorize everything, generalize nothing, and fall apart the moment the data shifts. And yet, they routinely learn useful patterns faster than we expect. So what's going on? Start with the engine, gradient descent. Imagine you're hiking in fog, trying to reach the lowest point in a valley. You can't see the whole landscape, but you can feel the slope under your feet. A network does something similar. It nudges millions, or billions, of weights in the direction that reduces error. That's not magic. It's a brutally consistent feedback loop. Predict, measure, adjust. The surprise is that this foggy hike somehow ends up in places that work. One reason is representation learning. Early layers tend to capture broad, reusable features, edges in images, rhythms in audio, statistical shapes in text. Later layers combine those building blocks into higher-level concepts. It's like learning an alphabet before writing essays. Once the building blocks are stable, new tasks become easier. Another reason is implicit bias. Even when a model could memorize everything, the training process often prefers solutions that are simpler in a specific mathematical sense, like smoother functions or smaller effective complexity. You don't explicitly ask for this. The optimization path nudges you toward it. That's why two models with the same architecture can behave differently depending on learning rate schedules, batch sizes, and regularization tricks. And then there's scale. Bigger models aren't just more memory. They create more routes through the lost landscape, more ways to fit the data well. Counterintuitively, that can make optimization easier, not harder, because there are more good enough valleys to land in. If you build things, art, products, code, this matters because it reframes what training is. You're not programming rules, you're shaping a learning process. Your data, your objective, and your evaluation set aren't accessories. They're the steering wheel. So next time a model learns something that looks like intuition, remember, it's not intuition. It's a massive system of adjustable parts finding structure, one tiny slope at a time.